Relative formalism for this problem was chosen because physics is the physical application of mathematics that relates to the sum of motion. This problem is from Chapter 3, question 116. The given problem is that the coefficient of static friction between a brick and a wooden board is 0.4, and the coefficient of kinetic friction between the brick and the board is 0.3. You place the brick on a board and slowly lift one of the board ends off the ground until the brick starts to slide down the board. Part A asks for what angle does the board make with the ground when the brick starts to slide. Part B asks for what is the acceleration of the brick as it slides down the board. For part A, an FBD was drawn and a right triangle was drawn to represent when exactly the board started to slide off of the, when exactly the bricks decided to start sliding off of the board. So the sum of X forces and the sum of Y forces were listed, and once the sum of Y forces were found and N was found, it was substituted into the sum of X forces. Once that happened, mu S was found to be tan of theta, and when tan of theta was rearranged to be equal to theta, then mu S was plugged in and the inverse tangent was taken of it. After the inverse tangent was taken of mu S, the degree theta was found to be 21.8014. Once that was found, it was plugged into part B. Part B summed up all the f of x forces to be mg times sine of theta equals mass times acceleration for x, x being parallel to the ramp. Here, a of x equals gravity times sine, and then the degree from the previous step was plugged in for sine, which was 21.8014. Gravity was plugged in, and then the answer for acceleration, part B, for x, again, which is parallel, was found to be 3.6433 meters per second squared.